Hey everybody, hopefully a really quick video now on these things called polyatomic ions. So far in our sort of course we've been talking about ions, and we've recognised that ions are just particles that have lost or gained electrons. So they don't have the same number of protons as electrons, and so that means that they have a charge. They're either negatively charged, that makes them anions, and those are the nonmetals, or they're positively charged, and that makes them cations, and that's the metals. So far we've been talking about simple ions, which we call monoatomic. Mono meaning one, atomic meaning atom, so one atom. So for example, some monoatomic ions we've been talking about are things like Na+, K+, calcium ions, 2+, magnesium, zinc, iron, lead, etc. Okay, so those are some monoatomic metal ions. We've also been talking about monoatomic non-metal ions, so things like chlorine, fluorine, bromine, oxide, etc. Okay. So far we've been looking at these sort of ions. These are called mono. Mono meaning one atom. Now they're quite simple because they only have one atom and they have their charge. So they look, once you sort of get your head around what ions are, they're not too difficult. There are, however, these other types of ions. And these other types of ions are called polyatomic. You can see in the title, polyatomic ions. Now poly means many. Okay, like polygon. So polyatomic means many atoms within an ion. So, for example, there is an ion called the sulfate ion. And the sulfate ion it looks like this, SO4 2-. So you can see how he looks a little bit different to the monatomic ions. He has lots of atoms. He actually has one sulfur atom and 4 oxygen atoms, all bonded together. They're stuck together in this molecule, and overall this particular molecule, this particle, has a charge. So if it has a charge, it's an ion, but he's not as simple as these monoatomic. So this guy is a polyatomic, many atoms, and that's called a sulfate. Has a special name. He's a sulfate ion. Now structurally, this is what a sulfate ion looks like. We've got an S, a sulfur atom, and he's bonded to 4 oxygens. So bond, 1, 2, 3, 4. Now don't worry about what I've drawn here, it's pretty messy. This is just trying to show that this structure is 3D, so it's like a tripod. This bond here is coming out of the page, so I'm trying to draw it like it's coming out at you, and this one here is going back into the page, and these lines are in line with the page. So we've got this molecule that's polyatomic, many atoms. And overall, I'm just going to put square brackets around here just to show this. Overall, he has a 2- charge. That's what the 2- is for. So overall, if we looked at this atom, if we went in there and could count up every single proton attached to every single nucleus in all of these atoms, and then we counted up all of the electrons that were here, we would find that there would be 2 extra negative charges overall, 2 extra electrons, so over this whole structure. So that's why it has a 2- charge. So that's what a polyatomic ion is. One other example might be nitrate, NO3-. So a nitrate ion. These are some common ions that you probably want to know if you're going into science next year, or chemistry. So a nitrate has one N bonded to 3 oxygens. Okay, and overall, this guy has a negative charge, -1 if you really want to put the 1 in. And so overall he has a -1 charge. So if we count up all the protons and all the electrons in here, there would be 1 extra electron. So he has an overall charge of -1. That's what a polyatomic ion is. I've got a little table here. I'm going to paste him in. So here's some common polyatomic ions. You can look down the list. There's the nitrate. There's the sulfate. And you can see that there's some positive ions as well. But these are some common ions. Now, I don't want you to be freaked out by polyatomic ions. They look complicated, they look tricky, but remember, the only thing we want to be able to do with ions at the moment is to be able to write formulae. So these ions, negative ions, get together with positive ions, like we talked about in previous videos, and they form compounds, ionic compounds. They stick together because of their difference in charges. In that sort of picture, the only thing that matters about these polyatomic ions is the same as what matters with the monoatomic. It's just their charge. Okay, so at the end of the day, what we really care about is the charge on these polyatomic ions. That's all. Yes, we have to look at the table and write what they are into the formula, and I'll show you that in the next video. But we only care about the charges. Don't get too worried about structures or these complicated things. There's a lot of numbers here, and we'll talk about that in future videos. But the most important thing with polyatomic ions is that you realize they're just like the simple ions, but they've got more atoms that are connected to them. The charges is what matters. Hopefully that's helpful.